Have you ever thought about a question? Water is transparent, a large block of ice we freeze at home. It is usually also transparent. But why is it that when we put ice cubes into a shaved ice machine to crush them, or pour a bunch of ice cubes into a cup, they unexpectedly turned white when stacked together? Could it be that the ice cubes were enchanted and changed color on their own? They are obviously the exact same thing, which is water molecules. Why is it that just the shape has changed, yet the color is completely different? Today, we are going to crack this visual magic of nature. To understand this magic, we first have to talk about what transparency means. Let's first think about how people actually see colors. In fact, it is because light hits an object and then reflects into our eyes. For example, why are black clothes black? Because they eat up and absorb the light. Then why do smooth ice blocks or glass looking transparent? Because they are very generous, letting light pass straight through. Light doesn't stay on them, nor does it reflect into our eyes. Therefore, our brain perceives them as having no color, which means they are transparent. So, with a smooth block of ice, light can easily passing right through it is like driving on a highway. But what if it's a pile of ice cubes or a bowl of shaved ice? Things are not that simple anymore. Imagine a ray of light happily wanting to pass through a pile of ice cubes. Between these ice cubes, there are countless gaps, and these gaps are filled with air. When the light enters the ice from the air and then runs back into the air from the ice, because the densities of these two things are different, the light is forced to turn. This is called refraction in physics. Not only that, when some light hits the surface of the ice cubes, it bounces back. This is called reflection. When a pile of ice cubes is stacked together, thousands upon thousands of interfaces between ice and air are created inside. For light, this is simply a giant super maze. Once the light enters, it keeps turning, hitting walls, bouncing back, and turning again. We give this process a very cool proper noun called multiple scattering, because light crashes around madly in this ice maze. Ultimately, all the light rays, including red, orange, yellow, green, blue, indigo, and violet, are all uniformly bounced out of the ice pile and enter our eyes from all directions. When all colors of light are added together, your brain receives this signal and tells you, oh, this is white. This is actually the magic of surface geometry. The shape of an object's surface determines the fate of light. A complete smooth block of ice has very simple surface geometry, but a pile of shaved ice has a very broken and complex geometric structure, full of irregular edges and gaps. That is what creates the illusion of white. If you don't believe it, you can do a little experiment. If you fill a bowl of white shaved ice with water, forcing out all the air between the ice pieces, at this time, the interfaces that light encounters become fewer, and you will find that the white shaved ice actually turns back into a more transparent state. In fact, this magic of turning from transparent to white is everywhere in our lives. Think about it, the clouds in the sky are white, but the small water droplets that make up the clouds are obviously transparent. This is also the result of a bunch of small water droplets randomly reflecting light. Also, when you play at the beach, the seawater is transparent, but the foam produced by crashing waves is white. This is similarly because the foam is filled with interfaces between water and air. Even that roll of transparent tape on your desk, when the whole roll is stacked together, the edges also look whitish, right? All of this is light playing hide and seek with the interfaces. So next time you go eat shaved ice, if a classmate asks you why shaved ice is white, you can push up your glasses and confidently show off to them, what I am eating is not ice. It is the perfect combination of optics and surface geometry. That's it for today's video. If you like us cracking scientific magic in everyday life, remember to like, subscribe, and share. See you next time. Bye-bye.